Here we go with 3A.6 Part A, sinusoidal function transformations continued. So, up first, we're going to talk about, at this point, we've learned that there are 4 variables for transformations, right? You have your A, your B, your C, and your D, right? And each one has a role to play. Okay? When A is greater than 0, that means that we're referring to A being what? Positive. So when A is positive, try that again. I don't know why it kicks me off. No, you don't need to calculate. When A is positive, we're going to talk about what do your key points look like. So when A is positive, our key points are, we have our x-intercept, then our max, then our x-intercept, then our min, then our x-intercept, right? Oh, it switched? That's why, yeah, that's what Ah, thank you. You saw nothing over there? We can fix that. Back to my snake. So our A is positive. When A is positive, again, it's going to be our x-intercept, then our max, then our x-intercept, then our x-intercept. When our A is negative, that's it's going to cause it to reflect over the x-axis, right? So it becomes x, then min, then x, then max, then x. Okay? So we're going to draw out our invert, our reflected. So we're reflecting. I tried really hard to make that symmetrical, guys. I tried really hard. Okay? Pretend that it is. It's easier to do with a pencil. Yes. Okay? No, this is a pen pad. It's different. Okay. However, you haters on my artwork, we're going to identify which piece each one affects, right? So when we're looking at it, everything is labeled. Your A is your, what is that called? Our amplitude. Amplitude, right? Our B helps us determine our what? Period. Okay. And our C, we want to point out what it is. It's our horizontal shift. But when you're looking at a graph, it's our starting point. It's where your phase is going to begin. So it's going to tell you where you start for that phase. Not if I shift. That's all we did for our assignment B. Did you have a plus C in your assignment B? No. You had the minus pi. You just had to tell me what it did. Well, then you should have moved your function. It shouldn't have been at the origin. Based on where it would be without that shift. No, you didn't need to say. Yeah, I don't think you had to graph it. You had to say what it did, right? Yeah. And D is our what? It's our vertical shift, but it describes our what? Midline. Describes our midline. Your D is, it's your vertical shift, but it also describes your midline. Because think about this. When there is no D, where's our midline at? 0. But when there is a D, it now has to move. Are we okay? Oh, crazy. See why we're making these connections now? All right, let's talk about again. Again, we're going to, just for the sake of us, what we've learned, we're just going to keep this as x minus c. Remember that x's are liars. Keep our lives. All right, So we're going to talk about when A is greater than 0, meaning that our A is positive. What are our key points going to represent? What starts off with cosine? Your max is going to be our max, then our x-intercept, right? Because that's our cup. Then we have our x-intercept, then we have our min, then we have our x-intercept, and then we have our max. Okay? So when A is less than 0, meaning that A is negative, what happens this time? We're going to be a min, then an x, then a max, and then a min. All right. Here I go really hard trying to emulate. I don't need y'all's criticism. Only your support. Please and thank you. No. I will try. I don't need no other. I've already told y'all. I only need your positivity about it. I'm going to be smart this time. I'm going to give myself some goals to make it to. I don't know why I'm going all the way to this corner, though. Because it's hard. And because it's the lowest point's right here.
Oh, but you can still go to the lines. Yeah, you can still. Yeah.
I feel like that's great. Do y'all see that? Look at her. She's beautiful. All right. So let's describe. Did anything change? Are these still going to be the same behaviors? Our C is going to tell us our what? Our start. Our A tells us our amplitude. Our D tells us our midline. And our B helps us find our period. Okay. Yes. Doable. Okay. So these vocabulary words you need to know. Okay. Yes. Amplitude, absolute value of your A. Your period. Your period is the length of one complete cycle. Your phase shift, that's your C, is the horizontal translation. Your starting point. How much did you go left or right? Right? Your D, your midline, is your vertical shift. Translates the graph up and down, which means your midline also has to move off the x-axis, right? Your B, the B value is the number of cycles in the interval, right? So how many cycles are present? And then when you're remembering, the expression is called the argument. So right here, B parentheses x plus C, it has to be in this format. Okay, well, minus C. I hate this lady uses plus C. Oh, X minus C. Huh? No, I don't know why she did it. Yeah. So X minus C, meaning that if it was written as, let's say I had 2x plus 4, that is not in the correct argument. Does that make sense? I would need to factor out so that X has a 1x. So I would divide out the 2 and I would get 2x plus 2. So my B value is 2 and my X value, my C value is also 2. Does that make sense? You're going to factor, yes. Your C value is only when it's in factored, not in factored form. It just needs to be divided out, separated. Okay. Yes. So like if it said cosine of 3 theta plus 6, this is not my C value. Does that make sense? My C value would come from me factoring out that 3 and it being 3 parentheses theta plus 2. Does that make sense? That's the argument it has to be in order for me to say, this is my C, this is my B. Got it? Okay, that has to be in that argument. Capiche? All right. So, with all of our skills and all of our powers combined, can we identify everything about this function and graph it? I believe in you, and you should believe in yourself. Okay? You're welcome. I do what I can. Okay. So when I look at this, I know that what? I know my amp. I don't know why I want to spell amp in a weird way every single time. My amp equals 3. My period equals what? My P equals 2 pi divided by 3, which is 2 pi thirds. My midline is where? It's still at 0, right? My midline is at y equals 0. Why is my midline at y equals 0? Because there's no d. So we're still at y equals 0. Okay. Where do I start? I do not. Remember, x's are liars. I'm starting at pi over 6. So now I'm starting at pi over 6. And from it's always minus e. It's going to end up being a minus. Yeah. Just ignore her. It's all. Yeah. It's going to be at pi over 6. Like you're adding pi over 6. You're starting. So now we know we're starting at pi over 6. We know that our amp is 3. And we know they have a sign. So because we're signed, it's going to be a x, then a max, then an x, then a min, then an x. So I'm starting at pi over 6. And my period is how long? 2 pi over 3. So pi over 6 to 2 pi over 3 is where my last point has to stop at. Does that make sense? So to figure out where I end, I'm going to have to do pi over 6 plus 2 pi over 3. How do I math that? My period is 2 pi over 3, so I know where I start. But to figure out where I'm ending, I have to do. You can do common denominator. You can quickly cross multiply, however you want to do it. I'm going to do multiplying, cross multiplying just to show you. So that gives me 3 pi plus 12 pi over 18. If you're not good at finding the least common denominator, this is going to always be your fastest way of doing it. Does that make sense? To cross multiply and multiply the denominator. So that's going to be your shortcut. If it's not like doing all of that. 3 plus 12 is 15 pi over 18 reduces to what? 5 pi over 6. So I know that my last x-intercept will be at 5 pi over 6. To find everything else, you're just finding the halfway point. Does that make sense? To find everything else, you're just finding the halfway point. So the halfway point between pi over 6 and 5 pi over 6 is where? Pi over 2. The halfway point between pi over 2 and pi over 6 is where? Pi over 3. The halfway point between pi over 2 and 5 pi over 6? 2 pi thirds. So this lets me know where everything is. Does that make sense? I know that my x-intercept is here, my max, and because of our amp, our max is 3. My next intercept is here. Because of my amp, my min is at -3. And I'm going to end at 5 pi over 6. That's what we did.
No, but if you want to do you have to have 4 or 5.
Yeah, you can go 1, 1, 6, 2, 6, 3, 6. As long as you make sure that this equals 4 pi over 6, then you could count 1, 6, 2, 6, 3, 6, 4, 6. And you know where it ends. Okay. If it asks me to continue this out, then I would repeat. So following this pattern, remember, it's just basically like copying and pasting what you did. So now I'm going to go, I'm already at an X and it's going to repeat again. I'm now going to go up to a max, down to an X, and then down to a min, right? So continue like so. Yeah, to finish the zero, it says, yeah. So then where zero would be? -3. So based on the window I have, this is a complete graph. How do we feel? Is it terrible?
Yeah.
What makes it terrible? Just because? It's cool. All right.
Yeah.
Okay. I'll take that. Because you are adding to your x's. We're technically adding to our, if you're thinking about from your parent function table, what your rule is to your x's. If you think about it in terms of a rule, to each one of your x's, you are adding pi over 6 and dividing by 3. That would be the rule that you're following. To each one of your y's, you're doing 3 times y. So this is the rule that's affecting your parent function. Does that make sense? And notice that for x, you're going to add or subtract first and then do the division, because that's inside of parentheses. So if you're wanting to revert back to being rules, which we learned, right, in the previous section was using the rule. If you wanted to look at it as a rule, to each one of your table values of your x's, you are adding pi over 6, then dividing by 3. The goal is to be able to look and do the shift without having to make the table every single time. But if the table is your friend, that's why we learned that method, then stick to it. Does that make sense? So if creating the rule and changing the table is how you feel confident, then I wouldn't make you change that. Okay?
What you have in the box right there, is that what you meant by the rule?
Yeah, this would be the rule that affects my parent function. Huh? Identifying where I'm starting, added my phase, count my midpoints. Because each one of these has a role. So my B value tells me where I start. So where my first x-intercept is going to be, or my first intercept with my midline is going to be. So my first intercept with my midline is going to be at pi over. There's 5 key points. Remember, we always focus on the 5 key points. It creates 4 parts. So there's 4 points that create 4 equal partitions. Okay. So the goal here is to try to build on our ability to do it and do it a little quicker, a little more mental, is what we're focusing on right now. Okay. So let's try again. So this time we have cosine. So we know that we're in the cup shape, right? So for cosine, we're going to identify what we have. Is that cool? We know that our amp, our absolute value of A equals 2. Agree? We know that our period equals what? 2 equals 2 pi divided by 1/2, which equals 4 pi. Okay, we know our C equals -2 pi, which means that this is where we are going to start. And again, what about our midline? We're still at y equals 0. Okay, so think about a cup. With a cup, is a positive cup. We're going to have a max, then an X, then a min, then an X, then a max, right? So we know where we start. Where do we start at? -2 pi. And how long is it going to take me to get from -2 pi to my end? 4 pi. It's going to take me 4 pi. My period is how long? 4 pi. So negative 2 plus 4 pi. Now say it, Anna. 2 pi. So my max here is going to end at 2 pi. And now all you're doing is finding the halfway between. What's halfway between negative 2 pi and 2 pi? 0. What's halfway between negative 2 pi and 0? Negative pi. Halfway between 0 and 2 pi? Pi. So these are where my max and my min values are going to be. Yes? All right. Bye, guys. So we have 2. Just, it was to get ready for your quiz.
So on this.
All right. So now we have all the things we need to graph. So we're going to start at negative 2 pi. It's a max. So we go up to 2. And then we're going to go to negative pi. And it's our x-intercept. Then we're going to go to 0. And it's our minimum. Then we're going to go to pi. And it's our x-intercept. And then we're going to go to 2 pi. And it's our maximum. So our graph looks like so. And again, bear with me on my drawing skills, but I think you can see where we were going. And then it's going to go, pew. Okay. All right. So when you're comparing contrast what occurs to the period when B is greater than 1 and when B is less than 0 and 1, what did you notice? So like our B on example number 1 is greater than 1. Our B on example number 2 is less than 1, but greater than 0. So what do you notice was happened? Well, we're going to go back to kind of our terms from Algebra 2, where we talked about a stretch and a compression. Do y'all remember those terms? So that's what applies here. So when B is greater than 1, that's a horizontal compression. Compression. And when B is between 0 and 1, visually, it's going to be a horizontal stretch. Excuse me, music. I gave a little break there. All right. When your real C value, oh my gosh, your real C value, because remember X is a liar, is less than 0, meaning that's negative. What did our graph do? Our graph went to the, not your real, well, yeah, your real, like what you see is less than 0 or appears to be less than 0. Oh, I'm not gonna do that. I'm gonna reword that. Sorry. When your real C value is less than 0, remembering that X's is liars. So in our problem, it's gonna appear as a plus C, right? That means that we're going to the left. When your real C value is greater than 0, then the phase shift is to the right. So it's gonna appear as a minus C. We're gonna go to the right. Okay, so keeping that in mind. Now let's talk about midline. So for our midline, that is our D transformation. So what happens, what makes us go up and down? All right, so when you look at example number 3, we're looking at sine X, just the parent function of it, and we're gonna go plus 1. So that means that our midline is now going up. So we're gonna go up. So instead of being on the x-axis, we're now our midline at 1. Y'all have to do now. Okay, so now our midline is here. We haven't changed anything. The main difference here is though our x-intercept. So when we apply to x-intercept, it's not necessarily the x-intercept. We probably should say intercept, meaning where it intercepts the midline, which would be the case here. So we're going to intercept the midline. Instead of being at the origin, we're now at 0, 1. We're now here. We're now here. We're now here. on the x-axis, and then we're going to come back up. So as you can see now, we are intersecting the midline. So therefore, it's not an x-intercept. It's a intersection of the midline when there's a D. Okay, and then the pattern would just continue. Okay. So you continue the pattern. And pew, pew, pew. Okay, so hopefully we're comfortable with that. And then now cosine, we're gonna look at cosine with a -2. So that means that our midline is now going down 2 units. So instead of being at the x-axis, we're now at -2. Okay, because we're at -2, that means all of our y values have been shuffled down by 2. So we're going to now be, instead of at 1, we're at -1. Again, it's now an intersection of the midline. So we're going to be here at -2. Then we're going to have our minimum down here at -3. Then we're going to come back up, and then we're going to intersect. And then this pattern just continues. So our cosine function looks like this after a shift, vertical shift up and down. So in terms of a rule, in this case, our x's aren't affected, but each one of our y's we add 2, right? In terms of the rules here, our x's aren't affected, but to each one of our y's, we are subtracting 2. And that includes your midline, obviously, okay? So therefore, if y equals sine A of b times x plus c, then it says plus c, we're going to go ahead and write minus, because it doesn't work in our world, minus c plus d, then the vertical shift of the entire graph is equal to d, okay? Which is the midline. Conclusion. So what I would like for you to do is go through, identify each variable. It's like a summary for you to do with your table partners, and put in your own word definition, what's going to help you remember for each one of these. If you need help, you can always come back and look at the video, but I do want you to take the opportunity and try. Yes. Welcome back. So our amplitude here is A, right? Our variable expression would be A. For our period, it's 2 pi divided by our B variable. Our phase shift is C, and our vertical shift is D, okay? So a way to remember that, your amplitude is going to be half the height of your wave. So it's always going to be half the height of your wave. So when you think about it, think about what is the average of your max and min. So it will be our max plus our min divided by 2. Okay, and it's going to always be positive. Okay, it is our vertical dilation. That's another thing you could have written. It's telling us how are we changing in that sense. Yeah. Okay, your period. Your period is the length of your wave. So it's the length of the wave. And when I refer to wave, I'm talking about the sine and cosine. So like the wave. So either your cup or your snake. All right. So key thing here is 1 full cycle. How long does it take me to make 1 full cycle? And by cycle, that's us following our rules of x max, x min, x. Or max, x min, x max for cosine. Your phase shift. Your phase shift is your how much you're going left or right. You could have written that. It's the key point. It's your first key point. Your starting point. You could have said, yeah, that's pretty much it. For us, just remember that x's are liars. All right. And then your vertical shift is your D, and it's your midline. So one thing you should have written was your midline, and it tells you whether you're going to go up or down. And it also tells you if you're going to reflect across the x-axis. Okay, I hope that some of the words you see up here are words that you had written down and completed while with your table. Other than that, that is it for 3A.6 part A.